Hi everyone, Orange Banana here. In this first lesson of Simple Physics, we'll cover the basics of projectile motion and go through a few questions to help you better understand the subject. Now you might be thinking, what is projectile motion? Well, projectile motion is when the velocity of a moving object has both a vertical component and a horizontal component. And that will result in the pen moving like this or this. Now as observed, the path of motion looks something like a parabola. And now the main reason it doesn't move in a straight diagonal is due to either an increase or decrease in the vertical component of its velocity. In the case of the pen, it was a decrease in the vertical velocity due to gravity. Now you might be asking, what are some forces that can change the y velocity? Well, firstly we have gravitational force, electric force, and magnetic force. But in today's lesson, we'll mainly be using gravity in most of our examples. Now, the first and probably the most important concept you'll need in projectile motion is the sine and cosine relationship. Z multiplied by sine theta gives you y, and z multiplied by cosine theta gives you x. Let's use what we've learned to calculate the vertical and horizontal component of a moving object's velocity. Let's say we have an angry man.
I'm always angry.
Now this guy, he's really angry. He decides to kick the orange. Let's calculate the vertical velocity and the horizontal velocity of this moving orange. Now we're given that he kicks the orange at a speed of 4 meters per second and at an angle of 30 degrees. Now we're tasked to find Vx and Vy. Vx being the horizontal component of the velocity, while Vy being the vertical component. To find Vy, all we need to do is multiply 4 by sine 30 degrees. And there we have it. Vy equals 2 meters per second. And that means the vertical velocity of this moving orange is 2 meters per second. To find Vx, all we need to do is multiply 4 by cosine 30 degrees. And we get 2 square root 3. That means the horizontal velocity of this moving orange will roughly equate to around 3.46 meters per second. The next most important concept you'll need is the four kinematics equations, with displacement referring to the total displacement up to that point in time. I made an asterisk next to the four kinematics equations, as these equations are only applicable when acceleration is constant throughout. So if you have a changing acceleration, you won't be able to use these equations. Do take note of these four equations, as they will be used heavily in solving projectile motion questions, as seen in later examples. Let's use the previous example of the man kicking the orange for our first question. We're tasked to find the total horizontal displacement of the orange. The first method we can use to tackle this question would be by using the four kinematics equations. Using S equals to ut plus half at squared, we can sub in the vertical displacement of the orange to be 0, as the orange would stop moving when it lands. And since it's on the ground, its vertical displacement is considered to be 0. So we can sub all the values we have in, and we get 0 equals to 2t, 2 being the initial vertical velocity, plus half at squared. We'll approximate acceleration due to gravity to be 10 meters per second squared, as it's an easier number to work with. And we give it a negative sign as gravity is acting downwards. So the final equation we get is 0 equals to 2t minus 5t squared. And this is a quadratic equation. You can solve it however you like. For me, I prefer the easier way and just keying it into my calculator. And we get t equals to 0.4. There's a negative value. However, as time cannot be negative, we just reject that answer. And so now we can multiply the time by the initial horizontal velocity, which is 2 square root 3, and we get 0.8 square root 3 meters as our final answer. The second method we can use requires more technical understanding. So let's take a look at the velocity time graph. When we differentiate velocity with respect to time, we get displacement. And that explains why the area under the velocity time graph is actually the displacement. So as you can see, when the orange reaches its highest point, its vertical displacement is A, and it's represented by the area bound by the velocity time graph. The vertical velocity of the orange is momentarily zero at this point in time. When the orange falls back down, its vertical displacement is represented by B. And since the orange total vertical displacement is zero, that would mean that A plus B equals to 0, which also means that A equals to negative B. So, what does this all mean? Since A and B are similar triangles as they are equal in magnitude but opposite in direction, we can conclude that the total time is 2t, where t refers to the time taken for the object to reach its highest point. Another conclusion that we can make is that v1 equals to negative v2. What this means is that the initial starting velocity is equal in magnitude but opposite in direction to the final velocity. Lastly, we can also conclude that the total time an object is in motion is the time taken for its velocity to change from v1 to negative v1. So if I were to launch an orange upwards at a velocity of 5 meters per second, the total time the orange would be in motion would be the time taken for its velocity to change from 5 meters per second upwards to 5 meters per second downwards. Let's use what we've learned for our second approach to this question. So we know that the total time the orange is in motion is the time taken for its vertical velocity to change from 2 meters per second to negative 2 meters per second. And since acceleration is the rate of change of velocity, we can find the time simply by taking the change in velocity, delta Vy, and we divide it by the acceleration. So we have negative 2 minus 2 divided by negative 10. Sorry, I forgot to include the negative there. And we get t equals to 0.4 seconds. And we can multiply this by the horizontal velocity, 2 square root 3 meters per second, and we can find the total horizontal displacement, which is 0.8 square root 3 meters. The second part to this question requires us to find the maximum vertical displacement of the orange. The first variable we'll need to find is the time taken for the orange to reach its highest point. In our first approach, we can equate the time taken for the orange to reach its highest point to be t. So t equals to change in vertical velocity over a being acceleration due to gravity. So we have t equals to final vertical velocity minus initial vertical velocity. And your final vertical velocity when the orange is at its highest point is 0 meters per second. So we get 0 minus 2 over negative 10. So we get 0.2 seconds as our time taken for the orange to reach its highest point. So now we can sub in the values that we have into our equation s equals to ut plus half at squared, u being the initial vertical velocity. And we can find our maximum vertical displacement, which gives us 0.2 meters. For our second approach, we'll need to utilize the lessons that we've learned from the velocity time graph. So as you can see, since A and B are similar triangles, T1 equals to T2, and T1 plus T2 equals to the total time that the orange is in motion. So what that means is that the total time the orange is in motion is 2 times the time for the orange to reach its maximum point. So for our second method, all we really need to do is divide the total time that the orange is in motion by 2. And since we already know the total time from part A, which is 0.4 seconds. We just divide 0.4 by 2 and we get 0.2 seconds as the time taken for the orange to reach its highest point. We can now sub in 0.2 seconds into our kinematics equation and we get 0.2 meters as our maximum vertical displacement. Let's move on to the second question. If we were to have a raised platform that is 5 meters tall and it's 8 meters away from a fire, if an orange were to fall off the counter at a speed of 10 meters per second, would the orange land in the fire? Well, again, the variable that we have to find here is the total time that the orange is in motion. Since we know that the vertical displacement of the orange is negative 5 meters as it moves down 5 meters from the height of the raised platform, we can sub in into our equation s equals to ut plus half at squared. We get negative 5, sorry, forgot to include the negative there, negative 5 equals to 0 since the initial vertical velocity of the orange is 0 plus half at squared. And we get the time to be 1 second. We can multiply the time by the horizontal velocity, which is 10 meters per second, and we get the total horizontal displacement to be 10 meters. And since the orange travels more than 8 meters, which is the distance between the raised platform and the fire, the orange will land in the fire. So let's move to our third and final question. We have an archer and his arrow is 1.5 meters above ground. He's 60 meters away from a little boy. The little boy, who's 1.3 meters tall, is standing on a raised platform of 0.3 meters. If the archer were to fire the arrow at a speed of 80 meters per second at an angle of 3 degrees, would he hit the boy? In order to better visualize this question, let's draw a straight line connecting the arrow and the boy. Next, we need to calculate the height of the boy that is above the straight line and the height of the boy that's below the line. I've already done the calculations on the left. The height of the boy that is above the line is 0.1 meters, while the part of the boy that is below the line is 1.2 meters. Now with that, before I reveal the solution to this question, I want you guys to leave your answers in the comments below. Will the arrow hit the boy? Go on, I'll wait. Alright, with this, we can now establish the fact that the arrow will hit the child if the vertical displacement of the arrow were to fall between 0.1 meters and negative 1.2 meters. The first step to finding the vertical displacement of the arrow is to find the time taken for the arrow to travel 60 meters. So the first thing that we'll need is the horizontal component of the arrow's velocity, which we can find by multiplying at, which is the initial speed of the arrow, by cosine 3 degrees, and we'll get 79.89 meters per second. This is rounded off to 4 significant figures. And in order to find the time, all we need to do is divide 60, which is the distance traveled, by the speed of the arrow, by the horizontal component of the velocity of the arrow, which is 79.89 meters per second, and we'll get 0.7510 seconds. So that's the time the arrow takes to travel 60 meters. And now that we have the time taken for the arrow to travel 60 meters, all we need to do is find the initial vertical velocity of the arrow. So what I've done is I've multiplied sine 3 degrees by its initial speed of 80 meters per second, and I got 4.186 meters per second. This is rounded off to 4 significant figures. Now we can sub it in into our equation of s equals to ut plus half at squared. And we find that the vertical displacement of the arrow is 0.324 meters. I've rounded the final answer off to 3SF. And since the vertical displacement is greater than 0.1 meters, the arrow will fly over the child's head. Lucky boy. Alright, anyway, thanks for watching till the end. If you found this video helpful, please do leave a like and subscribe to my channel. Comment down below if you want me to cover any other topics. Have a nice day.